DEX is a configuration language for security policies. It's an external DSL, and it deals with the domain of protecting websites and mobile apps from bot attacks. This is actually a major security problem. We've been using it in production for some years now, and you have probably used it indirectly. You just don't know about it. Many major websites from major airlines, hotels, banks, etc. are protected by this stuff, especially in the United States, but throughout the world. So DEX is a purely functional, statically typed language, and it's non-Turing-complete for the obvious reason that we do not want our configurations to loop indefinitely. So, bad idea. So the language prohibits recursion, it has no looping constructs, so the only way to iterate over anything is by list comprehensions, and lists are finite, and therefore execution always terminates. The DEX type system started out as a Hindley-Milner variant that works, but has some of the classic problems that Hindley-Milner has. Error messages are difficult to get right, very hard for users to understand. Small changes can have a large impact in seemingly unrelated parts of the program where everything is actually type safe, but the inference just fails because of unrelated changes. So we're transitioning to local type inference to deal with that. Interesting thing is how we handle nulls. The data we get in may often be null because it depends on various network settings, headers in web pages, things that have a lot of variation and often are undefined, in which case we get a null value, very much like in databases. So we have to have nulls, and we don't want to crash on nulls either, and so the semantics are that nulls are propagated. For example, if you call a function with a null argument, then the result is null. The function isn't really evaluated. Now, of course, you have to test for these situations at some point to catch these and produce a proper value instead. But missing this is easy and is a significant problem for us. A fair amount of cases where we have escalations or bugs, a large proportion of them are actually related to this. And so we're adding non-nullable types in the type system to deal with this. Execution is a mix of lazy and eager. Basically, it is demand-driven. Output constructs where we report values to the user are what drive the execution, of course respecting dependencies. They can happen in whatever order because it is purely functional. And the result is it's all demand driven, but when you actually call a function, all the arguments are evaluated. So that's applicative order, which makes it a bit easier to understand what's going on than in the classic lazy formulation, like in something like Haskell. So overall, we've had a great experience with this. This is a business critical function, and it works much better than most improvised solutions that you might imagine using XML or some other similar variant. But you do have many of the problems that you encounter in a classic full general purpose language. There's type systems. I haven't talked about the modularity, inheritance, various constructs that are there. See the full talk if you're interested. And the other big conclusion is that Turing completeness is overrated. We have been able to do pretty much anything we need for this language, but also to see that in most cases, what you do in a general purpose language would also work, and that has inspired to some degree the work on ShapeRank that I'm talking about elsewhere. So that's the lightning overview of DEX. Thank you very much for your time.